Welcome back to your favorite Fundamentals College Math class. We'll take a look at the normal distribution today. So, we'll be familiar with those properties as well as get into the empirical rule. So, one way to gather data is collect a random sample as representative. So, for example, we could, if you were to take a sample of female CSN students and record their heights, right? Well, maybe if you took a sample of 100, it might look like that. But as we take more heights, like maybe we took a sample, on the next one here of, maybe there's 1,000 students sample right there, right? This kind of like that, kind of like that. But as we take even more students, maybe we take 5,000 students, female students' heights, and you can see how it's getting better and better and better. If we smooth that out, we have a nice symmetric bell curve, right? So this is a normal distribution, also known as the bell curve. So as we get more and more heights, it gets not only more accurate, but it looks a little smoother in terms of its symmetry, right? Symmetric on both sides. So what are some characteristics of this bell curve or this normal distribution? Well, first of all, the mean, median, and the mode value are all right there at the middle. Okay, all right there in the middle. It is symmetric, so 50% of the data is below, 50% of the data is above that mean, median, and mode, right? As it goes out, values are more rare. So this is somebody that's super tall, would be out here, right? This is somebody that's super short, would be down there. And you can see the height of that data, the height of the bell curve there is kind of showing you that, right? The majority of people are within a standard deviation of left and right of that mean, median, and mode right there in the middle, right? So as it tails out, again, more rare. Now, almost all the area is within 3 standard deviations. So this is, again, mean, median, mode. This is 1 standard deviation above. This is 2 standard deviations above. This is 3 standard deviations above. This is 1 below, 2 below, 3 standard deviations below. Let's go ahead and see if we can't draw the normal distribution for these test scores. It says example 1. The test scores on a math exam are normally distributed with a mean of 72. So I'm going to use the mu symbol for mean, or you can use X bar, either one. So my mean is 72, and I have a standard deviation of 8. And we're supposed to draw this bell curve. So let's go ahead and draw best you can here our bell curve. Right in the middle is our mean. We got 72. And then I'm going to draw 1 standard deviation above. There's the 2 standard deviation. There's 3 standard deviation. There's 2 below, 3 below. And let's go ahead and go up 1 standard deviation. So notice the standard deviation is 8. So 1 standard deviation above a score of 72, so 72 plus 8 is 80. 2 standard deviations above would be 72 plus 8 plus 8. In other words, 80 plus 8, so 88. And if I go 1 more standard deviation above, 88 plus 8, I get 96, right? So this is somebody that scored 3 standard deviations above the mean. The mean was 72. So this is a very, very, very high score, right? Not very many students for this data set, obviously, are scoring that because you're so much higher, 3 standard deviations above the mean. Now let's go below. So 72 minus 8 gives us 64. That's 1 standard deviation below the mean. 64 minus 8 would be 56. 56 minus 8 would be 48. And so again, we've just drawn the bell curve, extending it out 3 standard deviations above and below the mean, right? Let's see if we can't answer some data based on a given bell curve here. So let's do this second one here. Let's answer the following questions. What is the mean? Hopefully you say, oh, I know the mean, median, and mode when it's a bell curve. The mean is 52. So is the middle number. So is the most often number. They're all the same on the bell curve when it's normal distribution. As for the standard deviation, well, I know that's 1 standard deviation above. So how much did it go up? From 52 to 62, my standard deviation would be 10. See how it goes up 10 again, and then it goes up 10 again, and then it's going down 10 to 42, and then down 10, and then down 10, right? So our standard deviation must be 10. Standard deviation meaning the average deviation from the mean. All right, now we're going to get into the empirical rule. This is also referred to as the 68, 95, 99.7 rule. Okay. If you look at these bell curves here in blue, purple, and what was that, green, aqua, some color there, all of them have the same mean, median, and mode, right? Middle number. All of them have the same middle. But like the really tall one, its standard deviation would be smaller than like this purple one that's more spread out. That purple one would have a bigger standard deviation, right? And so the empirical rule kind of helps us to order this and to examine this. So here's what your empirical rule, or 68, 95, 99.7 rule means. So this is saying that, you've got your middle, oh gosh, get your middle number. This is showing you, this is what's called the z-score. Z-score is 0, that's just your median. That's 1 above, that's a z-score 1. 1 standard deviation above, 2 above, 3 standard deviations above, and so on. This rule is saying 68%, if these are test scores, 68% of students are within 1 standard deviation of the mean. 95% of the students are within 2 standard deviations of the mean. All but 5% will be within 2 standard deviations. And finally, almost everybody, but not quite, 99.7%. 99.7% of the students will be within 3 standard deviations above or below the mean, right? Now remember, 100% of the data, or 100% of the students is all below that thing, right? So it's almost taking care of everybody, but not quite, not quite. So here's just another look at those colored out, right? So 68% is within 1 standard deviation, 95% 2, almost everybody, but not quite, 99.7% within 3. So let's see if we can't make sense of this with our first example. Let's say we have a mean of 510. This is some standardized test. And then it tells us we have a standard deviation of 95. So let's go ahead and put on our test scores here on the bottom. So it's a mean of 510. It's right in the middle. Okay, and then I go up 95 from that, so 605. 510 plus 95 is 605. 605 plus 95 is 700. 700 plus 95 is 795. Now let's go down. 510 minus 95 is 415. Minus another standard deviation, so 415 minus 95 is 320. 320 minus 95, 225. Now let's throw our empirical rule on there. 68% of the students score between 415 and 605. That's 68, right? 68% of the students are scoring between there. between 415 and 605. Now let's do the next one. 95% of the students are going to score between 320 and 700. and 700. And finally, 99.7% of the students score between 225 and 795. You guys, this is a great time if you want to pause the video. I would go ahead and pause the video and make this a U-try problem. You've got a mean of 62 and a standard deviation of 7. So right in the middle, you've got your 62. And then I'm going to go up 7, up 7, up 7. Now 62 minus 7, 55 minus 7, 48 minus 7. Okay, I filled out. These are more test scores, it looks like. I filled out my test scores on the normal distribution. And I'm going to use my empirical rule. Let's go ahead and draw in the empirical rule. Oops. 68% of the data, 95% of the data, and 99.7% of the data. Okay? So if you look at the first one, part A, it says, what percent are between 55 and 69? Well, that's easy because it's one below and one above. And so we're going to hopefully answer that's an easy 68%. 68%. How many are between 48 and 76? 2 standard deviations below to 2 standard deviations above. And hopefully you say 95%. The last easy question here is between 41, which is 3 standard deviations below, and 83, 3 standard deviations above, will be 99.7%, right? Okay, so now then, what about between just 62 and 69, right there? Oops. Just between 62 and 69. Well, we know 55 and 69, right? If I fill that one in right there, we know that's 68%. Well, what's half of 68%? 34%, right? Would be between 62 and 69. Now, how about less than? Less than 62. So let me do less than 62. Whoops. Gosh, I'm really messing this up. Now that keeps going all the way. Whoops. It goes all the way down, right? Remember, there's 100% of the data under the curve. 62 is right in the middle. So half of 100%? 50%. Right? It goes clear down, even below 41. Right? There's hardly anyone down there below 41, but there are some. Okay? How many are less than 69 then? Less than 69. So I've got the one in red, plus I've got to add in the blue right here as well. Whoops, the blue. Remember the blue was, this was 34%, half of 68%, right? And the red was 50%. So 50 plus 34, 50% plus 34%, 84% on that. And so that's kind of how you want to be thinking about these as you're working these examples. All right, let's go ahead and fill this data in again. It looks like I have a mean of 76, so that's right in the middle here. 76. I got a standard deviation of 8. So 76 plus 8, 84. 84 plus 8, 92. 92 plus 8, 100. Now let's go down. 76 minus 8, 68. 68 minus 8, 60. 60 minus 8, 52. These are our exam scores. Now it also tells us there are 800 of these scores in this, of 800 data values, right? So the huge large scale assessment or something, maybe it's at a school or whatnot. Part A, how many students scored higher than 76? So we want to know everybody above the median, including way up there. Well, we know 100% of the data is below the curve, so that's got to be 50%, right? So we know 50% would be higher than 76. First of all, that's 50%. So then when we go to solve part A, 50% scored higher than 76. But we want to know how many students. Well, how many students took the test? 800, right? So 50% of 800, there's 400 students that scored higher than 76. 400 students. All right, let's do part B now. Part B is asking, how many students scored between 68 and 84? Well, we know 68% of students scored between 1 standard deviation below, 1 standard deviation above. All right, part B, 68% scored between 68 and 84, but we want to know number of students. So 68% of 800 will give us 500. There's 544 students scored between there, right? Part C, how about between 60 and 92? As you might expect, that's 2 standard deviations below to 2 standard deviations above, which is 95% of the students. So part C, 95% scored between 60 and 92. So how many is that? 95%. There's 800 students taking it. That's 760 students total. Okay, part D. How many students scored between 76 and 84? Okay, so now we're just asking 76 and 84. So that's half of, that's half of 68%, right? Between 76 and 84. So we know there's 34% of students scored between there. So part D, 34% scored between 76 and 84. But we want to know how many students that is. Well, 800 students took it. 34% of 800 gives you 272 students. All right, now let's go lower than 68, part E. Let me erase this here. Lower than 68. Let me put that in red. Lower than 68. Now that is down below, clear past 52, right? And remember, in here is 34%. And we know 50% of the data is below there. So 50 minus the 34% would give us the red, right? 50% minus that 34% would give us the red. Equals that tail that's below 68, lower than 68. So 16% scored lower than a 68. Well, how many students is that? Well, 16% of 800 is 128 students. 128 students. All right, let's do this last one. Now we want, let me erase this. lower than 84. Lower than 84. Here's our 84, so we want lower than 84. Well, we know this is 34%, and we know everything below the 50th percentile, everything in black, is 50%. So 50% plus 34% is 84%, scored lower than 84, right? 84 and below. 84%. 50% plus 34%. 84% scored lower than 84. So 84% of the 800 students, 672 students. And that's a nice little introduction to the empirical rule, 68, 95, 99.7 rule. Thanks so much for watching, taking notes. See you next time.